Okay, so in this example, we're being asked to find the points of intersection, and we're dealing with a line and a circle. So real quick, if you have a circle and then you have a line passing through that circle, you are essentially going to have 2 points of intersection, okay? And now, in order to do this video here, you have to know how to solve a system of equations, because we know that when we solve a system of equations, and in this case here, it's going to be a 2x2 system of equations because we have 2 equations and 2 unknowns being our 2 variables. But when you solve a 2x2 system of equations, or any system of equations for that matter, you are essentially finding the point of intersection. So when I solve this system here, I should be getting 2 points. Now, I'm assuming it's passing through at 2 points here. It could be tangent. So for example, you could have like a tangent line to this circle, something like this here, where you'd actually only have 1 point of intersection. But again, we're going to be able to tell once we solve for our variables, we'll know because we'll only get 1 point rather than 2 points, okay? So if you don't know how to do a system of equations, make sure you check my videos below. I'll drop the link. That way you have access to that content. And with that being said, let's talk about how we're going to do this problem here. So let's go ahead and get rid of all this here. And so we're assuming we're going to have 2 points of intersection here. And then we're going to solve it as a system of equations. So, you could use elimination, but this problem here is set up really nice for substitution because on equation 2, this one right here, I have y equals. And I can essentially plug that into equation 1 wherever I see a y being right here. Now, before I do that, look at equation 1, okay? You can go ahead and simplify this down so that you're not dealing with that coefficient of 25 out in front of the x squared and the y squared. So for example, if you take equation 1 and you simply just divide all of your terms by 25, it's going to be much easier to work with. And when you do that, you get the following. You get x squared plus y squared equal to 1. Because again, I'm doing 25 divided by 25, I get 1. And again, nothing has changed here, right? You've balanced out the equation. So again, if you were to graph this here and you were to graph this here, you're going to get the same exact circle. But this one on the right-hand side, right, is way easier to work with. So what I'm going to do now, I'm going to take y, which is 3 over 4x, and I'm going to plug it into this y right here. And then I'll have everything in terms of x. I can solve for x and then go from there. So for example, I'm going to have x squared plus, now here's my y, I'm going to plug in what y is. It's 3 over 4 x, right, and then squared, equal to 1. All right, so from here, we're going to solve for x. To do that, I'm going to go ahead and apply this exponent to this term inside. When you do that, you get x squared. Now remember, you have to apply that to both the numerator and denominator. So you're going to get 3 squared, which is 9, and then 4 squared, which is 16, and then x squared, which is x squared, right? Equal to 1. So from here, how do you do it? Well, I have a fraction here. I have 9 over 16, right? I can go ahead and combine these like terms right here. Remember, there's really a 1 out in front of this x squared, and it's actually 1 over 1, right? And so I'm going to go ahead and combine these fractions. So off to the side here, I'm going to write 1 over 1 plus 9 over 16. I'm going to leave the variable out for now. And I'm just going to get a common denominator here. So all I have to do is multiply this fraction here by 16 on both the top and the bottom. So I'm going to multiply here by 16, same thing here, and then I can get my common denominator. When I do that, I get 16 plus 9 all over 16, right? And from here, all I have to do is combine my numerator. So when I do 16 plus 9, I get 25. So I get 25 over 16. So now I have 25 all over 16. This will give me x squared equal to 1. Okay? So to solve for x squared, we're going to multiply both sides by 16. We're going to get rid of that denominator, right? This will cancel, right? 1 times 16 is 16. So now you have 25 x squared equal to 16. Divide both sides by 25, and then you'll take the square root, right? So why don't we go ahead and move down? So I'm going to go ahead and divide both sides by 25. So dividing by 25 here, cancels, divide by 25 here. I get x squared is equal to 16 all over 25. And so from here, I'm going to take the square root on both sides. Okay, this will cancel. And so now I get x is equal to plus or minus square root of 16 all over 25. And we want to go ahead and apply that square root to both the numerator and denominator. So when you do the square root of 16, you get 4. And when you do the square root of 25, you get 5. So I end up with plus or minus 4 over 5. Okay. So those are my x values. I have two x values here. I have x is equal to positive 4 over 5, and then I have x is equal to negative 4 over 5. Now I have to get my y values, and I'll have my 2 points of intersection after I do that. So how do I get my y values? Well, you go back up to the original equations, right? And you want to pick the easier of the two. So I'm going to pick this equation right here, right? It's much easier. You could pick the top equation, but it's going to be more work because, again, you have those squared values in there. So I'm going to go ahead and use the bottom equation, and then I'll solve for y, okay? So doing that, again, we know that for x, we got plus or minus 4 over 5. So I'm going to write here y is equal to 3 over 4 times, now I'm going to use the positive version. I'm going to say 4 over 5 positive, okay? And then I'll solve for y. Well, this one works out nice because the 4's will cancel out, okay? And I get y is equal to 3 over 5. All right, so I now have a point. I'm going to go ahead and record that point, and it's going to be the following. I plugged in 4 over 5 for x, okay? And I returned positive 3 over 5. So there it is, okay? So here is one point of intersection. We're going to go ahead and box that in, all right? So now we're going to do the same thing, except now we're going to grab negative 4 over 5, and we're going to solve for y. So let's go ahead and scroll down, okay? So let's go ahead and write that in. We get y is equal to 3 over 4 times negative 4 over 5, right? The 4's will cancel. I still have this negative here. It becomes y is equal to negative 3 over 5, okay? And so that's going to be another point. So I'm going to go ahead and record that. So now the second point is going to be negative 4 over 5. That's what I plugged into x, comma, negative 3 over 5, right? And so this is done, okay? So I have my 2 points of intersection. So yes, that line is intersecting that circle at 2 different points, and there they are in red, okay? All right, let's try another example. This one will be a bit more challenging. So here's our next example, and you can see that, again, we have a circle here, and then we have a line, right? And so again, they want us to find the points of intersection. And remember, there's always the possibility that this line right here could be tangent to this circle, meaning it's only going to have one point of intersection, but we'll be able to figure that out as we solve the system of equations, okay? So to do this one here, again, I'm going to use substitution because I already have y equals. And this one's going to get a bit messy because you have these fractions here, all right? And so there's going to be a bit of work that you have to do. But I'm going to plug this y value into this y value here, and then I'll go ahead and solve for x. Okay, so for example, I'm going to write x squared plus, now here's my y. I'm going to plug in what y equals. That's going to be negative 4 over 3x plus 5 over 3. Close it, and then we have to square it, okay, equal to 1. Now, this is where it can get a bit messy because you actually have to do FOIL here. Right, I have a binomial right here, and it's being squared. I have to FOIL it out. So for example, when you FOIL this out, we're going to write it side by side. I'm going to say here negative 4 over 3x plus 5 over 3 times the same thing. Negative 4 over 3x plus 5 over 3, right? And then close it. So again, we have to do FOIL here. That's first, outside, inside, last to expand it out. So when I do first here, what do I get? I'm going to multiply this term and this term. I end up getting positive 16 over 9 x squared. So I get 16 over 9 and then x squared, okay? Then I have to move on to outside. So that's going to be this term here and this term, okay? Well, what will that give me? That's going to give me negative 20. So negative 20 all over 9. And again, I have an x there. When I go ahead and do inside, again, that's going to be right here and right here. I'm going to get the same thing. I'm going to get negative 20 over 9x. So negative 20 over 9x. And then doing last, I get 25 over 9. Again, I do 5 over 3 times 5 over 3. When I do that, I get plus 25 all over 9. So from here, we want to go ahead and combine like terms. I can combine these terms together and they have the same denominator. So it's going to end up being negative 40 over 9. Again, I can combine my numerator, right? And write it underneath the same denominator. So you get negative 40 over 9x there. So we're going to go ahead and rewrite this whole problem. I get x squared, right? This part right here. And then plus 16 over 9 x squared minus 40 over 9x, and then plus 25 all over 9. And again, this will all be equal to 1, okay? So you can see you kind of have like a mess of a problem right now, but we're going to fix that and clean it up because look, I have a denominator of 9 here, denominator of 9, denominator of 9. I can get rid of those fractions. I have an equation here. If I simply just multiply all of my terms by 9, I will no longer have fractions, right? So that's what I'm going to do. I'm going to now take this equation. I'm going to multiply everything by 9. That way it's much easier to work with. So I'm going to scroll down here. And so if you multiply everything by 9, right, this becomes 9x squared. Again, multiplying this term by 9 will cancel out the 9. So now you're going to be left with just 16x squared. So plus 16x squared, multiplying the next term by 9, you're left with negative 40x. So negative 40x. Multiplying this one by 9, you get plus 25. And then multiplying 1 by 9, you get 9. Okay? So now you can see that it's going to be much easier to combine my like terms. I have like terms here and here. We're going to go ahead and combine that. We get 25x squared minus 40x plus 25 equal to 9. Okay? So at this point here, you can see that you're dealing with a quadratic. And so how do we solve quadratics? Well, typically, right, we're going to try to factor it. And if we can't factor it, then we rely on the quadratic formula, okay? So my first step here, I'm going to try to factor it. Now remember, whether you're factoring or using the quadratic formula, you always have to set it equal to 0. So I have to take this 9 and I have to move it over, okay, before I do anything. So I'm going to go ahead and do that. I'm going to scroll down. And so when I set it equal to 0, I'm going to get 25 x squared minus 40x, and then I'm going to do 25 minus 9, right? That would give me positive 16, okay? This will be equal to 0. And so from here, we want to see if we can factor it. Now, if you don't want to factor it, you could always just plug it into the quadratic formula, but I'll try to factor it. So looking at my coefficients here, I have a 25, I have a negative 40, I have a 16. Is there any number that will go into any of those numbers? And the answer there is no, right? There's no number that will go into all three of those evenly, right? So in this case here, we actually have to use the quadratic formula, which isn't a big deal, but I'm going to go ahead and label my coefficients A, B, and C, right? That's a quadratic in standard form. And if you're on this video, you should be familiar with the quadratic formula. So I'm not going to write it out. I'm just going to go ahead and plug it in. So again, I'm going to scroll down again. Let's see what we end up getting. So the first part of the quadratic formula is negative b. That means I'm going to plug in a positive 40. So x is going to be equal to positive 40, right? That's my negative b, plus or minus square root of b squared. Well, for me, that's going to be negative 40 squared. So I'm going to put here in parentheses negative 40 and then square it and then minus 4 times a times c. So minus 4 times a, that's 25, times c, that's going to be 16, okay? And then it's all over 2 times a. So I'm going to go ahead and just write that in. 2 times a is going to be 50, okay? So from here, we want to clean up what we have underneath the square root and see what we get there. And so plugging it into your calculator, you get negative 40 squared minus 4 times 25 times 16. Plugging that in, you actually get 0. And so this whole part underneath the square root ends up being 0. So when I take the square root of 0, it's just going to be 0. Meaning I'm just left with this part here and this part here. So x is going to be 40 over 50. So I'm going to put here x is equal to 40 over 50. And we know that the zeros will cancel out here. And so x is going to be 4 over 5. And so look what happened here. I do not have two x values here, right? I only have one. Right? It's not plus or minus now. I only have positive 4 over 5. So what do you think is happening here? Again, I have a line and a circle. And so what's actually happening here, this line is going to be tangent to the circle. So again, if I were to draw out a picture, right? Here's a circle. A tangent line would look something like this here, right? Passing through exactly only one point on that circle, okay? So that's essentially what is going on here. And so now I have the x value of that point of intersection. Now I have to get the y value. And to do that, I go back to my original equations, plug it in, and I'll get y, and then I'll be done. So again, x is 4/5. We're going to scroll up, and then we're going to plug it into our x value right here on this equation, right? Again, you could plug it into this one if you wanted to. I just don't want to deal with the squared values there. So I'm going to say here, y is equal to -4/3. We know that x was 4/5. That's what we got. So 4/5 plus 5/3. Okay, so when I do this out, what do I get? I get y is equal to -16 all over 15, okay, plus 5/3. So I can combine these fractions, right? I see that I have a denominator of 15 here. I have a denominator of 3. So if I just multiply that second fraction, both top and bottom, by 5, I'll get a common denominator that I need, which is going to be 15. So I'm essentially going to multiply this fraction again, both top and bottom, by 5 to get that common denominator of 15. When you do that, you get y is equal to -16 over 15 plus 25 all over 15. And then from here, we just combine. So -16 plus 25 will give you +9 all over 15. So y is equal to 9 all over 15. Okay? So now we can put it all together. Now we have our point of intersection. So we plugged in a 4/5 for x. I'm going to put here 4/5, comma, and we got 9/15. So 9 all over 15. And actually, if you want to reduce that, you can. We know that 3 goes into 9 3 times. 3 will go into 15 5 times. So I can actually reduce that. Let me go ahead and do that. Instead of calling it 9/15, we're going to call it 3/5, right? And now we're done. So here is our point of intersection. And again, this is telling us that this line is going to be tangent to that circle, right? So it's only intersecting at one point. All right. So that is it. That is how you can find the point of intersection if you're dealing with a circle and a line. Again, you simply do it by doing a system of equations. And if you don't know how to do a system of equations, again, I have those videos linked below. So make sure you check them out. And that's pretty much it. So I hope that you found the video helpful. I hope that you gained something from it. And so if this video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future. And I'll see you in the next one.